Try it right now. Run your fingers across your own ribs. Nothing. But if someone else does it, you lose control. You've probably laughed it off. I'm just not ticklish. Or I'm way too ticklish. Either way, you never asked why someone else's fingers can, and yours never could. And the answer isn't in your skin. It's not in your nerves. It's not even in your body. Scientists found something about this. It changes everything. Every sensation you've ever felt. We'll get there in about 4 minutes. But first, you need to understand the moment you try, the exact half second when you reach for yourself. Because what your brain does then is extraordinary, and it happens every single day without you ever noticing. Every time your body moves, something happens first. Before you've moved a single muscle, your brain sends out a signal, not to your hand, to itself. It's called an efference copy, a carbon copy of the movement, sent before you even act, 1 fraction of a second early. Think of your brain as a film director. Before every scene, it already knows the script, it knows the camera angle, it knows the words, it knows what happens next. So when the scene plays out, nothing surprises it. And that's what happens when you try. Yeah, your brain already wrote the scene. It knows the pressure, it knows the angle, it knows the speed. By the time your fingers land, it's already cancelled the sensation. In 2006, Sarah-Jayne Blakemore ran a study. University College London. Journal NeuroReport. She mapped the cerebellum, that's the cerebellum, at the back of your skull. She tracked it in the milliseconds before self-touch. Her team found something specific. The cerebellum suppresses your own touch, not passively. Actively, it reaches into your sensory system and turns down the volume. That's not a metaphor, that's a measurable neural event. Blakemore's team didn't just observe it, they recorded it in real time, millisecond by millisecond. Your brain actively intervening before the signal even reaches awareness, before you can feel anything at all. Your skin isn't less sensitive. Your brain is choosing to mute you, but that's only half the story. Because here's what nobody ever told you. This system, this self-canceling mechanism, it isn't just about tickling. It's running right now. Every second you're alive. And what this says about you, specifically about how much of what you feel is real versus constructed, we're getting there. But first you need to see what happens when this system breaks. And what comes next is even stranger. In 2000, a neuroscientist named Karl Frith, University College London, he published in Nature Reviews Neuroscience, and what his team found stopped the field cold. They studied patients with schizophrenia, specifically, those who felt their movements were controlled by something outside themselves, and those patients could tickle themselves, not metaphorically, literally. Their cerebellum wasn't matching intention to movement. The efference copy was arriving wrong, or not arriving at all, so their brain couldn't cancel its own touch. Their own fingers felt foreign, felt like someone else's hands. Let that sit for a second. The only difference between your hand and a stranger's hand is a signal your brain sends to itself. Remove that signal, and your own body becomes alien. But here's where it gets strange. This isn't just about touch. Think about that voice in your head, that internal monologue, running constantly. Your brain knows it's yours because it generated it first. It sent itself the efference copy, before the thought even formed fully, so you experience it as yours. But here's the disturbing part. The system that separates your touch from a stranger's is the same system that separates your thoughts from intrusive ones, the same system that makes you an author, and not just a passenger. Remove it and your own mind becomes foreign. Your own ideas start to feel planted. Your own body feels occupied. That's not science fiction. That's what Frith's team documented in real people, in a real lab. And the gap between them and you is one signal, one prediction, 1 fraction of a second. But there's more this system does. So here it is, the answer we promised 4 minutes ago. You can't tickle yourself because your brain predicted every move before you made it and cancels the sensation before it arrives. But what makes this truly strange is that your entire experience of reality works the same way. Every sound you hear, every texture you feel, every image you see, your brain is not receiving the world passively. It's generating a prediction first, a full simulation of what it expects. And then it only updates when something doesn't match. This is called predictive processing. Karl Friston, University College London. He spent 2 decades mapping this. His conclusion is radical. Your brain is not a camera, it's a hypothesis machine. It builds a model of the world. It filters everything through that model. Only surprises get through at full volume. Everything expected gets muted. That's why your own touch is silent. You expected it. That's why a stranger's touch is electric. You didn't. The most shocking moments of your life, they all share one thing. They broke your brain's prediction. You were certain of what came next and you were wrong. We thought the nervous system received information. But here's what that framing missed. It was always about filtering it. But what if the thing you call paying attention is actually your brain failing to predict? What if every time you felt truly alive, truly present, it's because your model broke? What does that say about your life? The parts that feel routine, safe, invisible. But there's another layer, and it might be the strangest part. In 2013, a philosopher named Andy Clark, University of Edinburgh, he published a book called Surfing Uncertainty. And his argument is uncomfortable. The more familiar something becomes, the less your brain processes it. A relationship, a city, a job, your brain already knows the script, so it stops paying full attention. It mutes the signal. Think about your commute. You stopped seeing it years ago. Same streets, same turns, same faces. Your brain predicted all of it. So it stopped rendering it in full. You were there, but you weren't watching. Think about a city that was once new. You noticed everything. The smell of the air, the color of the signs, the way strangers walked differently. Your brain was failing to predict constantly. And you called that feeling being alive. You're not bored because nothing interesting is happening. You're bored because your brain predicted everything correctly. And the world didn't get smaller. Your model got too accurate. And that's a problem nobody warned you about, because the same brain that protects you from overload is the one quietly dimming your life. Every repeated conversation, every familiar room, every face you've known too long, your brain filed them years ago. It stopped updating the file. What you see is the memory of them, not the person, not the place, the cached version, a copy of a copy, already fading, already gone. And here's what changes everything. The reason a new city wakes you up. A new person makes you feel like yourself, more than familiar people do. The reason risk and novelty feel like more life is prediction error. They break the model. They pull your brain back to full reception. Every time you stepped into the unknown, every time something caught you off guard, your brain did what it does with strangers. It couldn't cancel it, so it had to feel it. You've tried it. Of course you have. You were young. You ran your fingers across your ribs, pressed into the sole of your foot, touched the side of your own neck, felt nothing. And maybe you thought that's just you, but you weren't built for nothing. You were built for surprise. Your brain runs a simulation of the world every second of every day, so precise, so fast that most of life passes through you, muted, expected, already known. And every once in a while, a voice, a view, a moment at a frequency your model never saw, and you feel it fully, not because it was louder, because you never saw it coming. That's not luck. That's not chemistry. That's your brain, briefly, losing control of its own script. Blakemore was studying touch in 2006. She was mapping a reflex. But what she found, what Frith documented, what Friston formalized, what Clark put into language, is that the question was never about tickling. It was always about this. How much arrives at full volume? How much do you actually feel? How much is your brain silently canceling before it even reaches you? How often are you living inside predictions so airtight that nothing real gets through anymore? You can't tickle yourself. But something, somewhere, still can. If this changed how you see yourself, subscribe. That's exactly what this channel is about.